Welcome my dear students. So today we will discuss the meet in a middle technique, right? So first of all we will briefly discuss the what is the meet in a middle techniques, how we will useful these type of problems in problem optimization, then we go for the one example, right? So now we can see meet in a middle technique is a design strategy used to optimize the computational problem. That means that there is a one problem P, right? So this problem should be reduced to the or optimized to the some extent problem P should be optimized. So that should be the computational problems. So it is related to the specifically computational problem. It is a meet in middle design strategy, right? Second one, it is mainly applied to reduce the time complexity. That means that if it is any problem is taking big of 2 power n, right? So it is reduced to the time complexity of some big of linear or something. Just I am saying example, it is not necessary same, especially in a with a large space. So that means that simply we can say this strategy meet in a middle technique specially used for reducing the time complexity from higher time complexity to the lower time complexity. This is the second point, right? Third point, so this technique works divide the problem into the two small sub problems roughly equal size. That means that if any problem is there, this will be divided into the two parts. So that is the sub problem 1, sub problem 2, right? So this problem divided into the two sub problem, that is the equal size, roughly equal size. That means that not necessary the 100% equal size, right? For example, take the binary search. If it is array having 5 elements, so we cannot divide the array into the two equal parts. So either left side will be the 3 elements, right side will be the 2 elements, or vice versa. So that is kind of strategy this is following, right? So next step is a intermediate result from the both sub problems are combined efficiently to get the final results. So that means that this is the intermediate sub problem, right? So P problem is divided into two sub problems. So this is the intermediate problem, it is not final solution. So these intermediate sub problem solutions can be combined to get the total solution. So this is the one of the beauty in the middle technique. So where we can use, it will be commonly used in a exponential problems. So which is exponential problem, that will be in a cryptography, a combinational search and optimization task. So these kind of areas, so meet in a middle technique is going to be used, right? So next one we will discuss the basic idea of the meet in a middle techniques, how it will be actually performed, right? So what it will do in step number 1, a problem will be divided into the two smaller or independent sub problems. So that means that there is a one problem P, the problem will be divided into the two smaller sub problem, that is a P1, let us say P1, P2, right? These two problems are divided and independent sub problems. That means that the problem P1, P2 don't have any relation. So that is a step number 1. So each problem, step number 2, each problem is solved separately and partial results are stored. So that means that here it is a P1, P2 will be solved individually, there will be obtained partial results of P1 and P2, right? So these partial results are stored into the some space. So somewhere it will be stored. And next step, these store results matched combined to construct the final results. So we may can see the these steps also, step 1, step 2 in the diagram also, right. So after this matched results will be stored into the final solution. So this is the step number 3. So next one, so this approach what significantly reduce the time complexity from big of 2 power n to big of 2 power n by 2. How it is reducing, we will see the one example, so that you will understand the better way, right. So why it is reducing? Because of we initial designing strategy itself, we divide the problem into the 2 sub problems. So obviously what is the time complexity is taking n, it will be divided into the 2 power n. So next one is a it achieve the faster execution by trading additional memory usage for speeds. So that means that it is consuming the some additional memory, but it is doing the very fast. So this is the beauty about the meet in a middle technique. So we will see the one example, so that you will understand the clear in nature. You will get the clear idea, right. So we will take the one array which is A is having some array. Here don't concentrate on syntax and all those things. So try to concentrate on the logic. 5, 3, -1 and 7. So S equal to 13. Let us say assume. Right. So now I am taking an array which is A. S is a 13. That is not. I am taking sum of subset for loop. Sum of subset for loop. So let us say A for time being you assume the A is a array. A is a set. We have given set number, set elements, 3 elements. 4 elements. In a 4 elements, I want to find the sum is 13. How I am finding? I have to pick the sum elements from the set. It should be the 13. For example, you select the 5 first element, 5 plus 3, 8. It is not 13. So 5, 3 is a subset from the set A. So like that I want to find the S equal to 13. So first there are 3 different approaches is there. How we will solve this problem, we will see. So before going to the actual applying the meet in the middle technique, we apply the brute force technique, right. After brute force technique, we will go for the meet in middle technique, so that you will understand the very clear, right. So now, so in a brute force technique, what is a brute force technique? Brute force technique means we have to apply the all possibilities by using the these 4 elements. So that is a brute force technique. So what I can do, first I select the subset size is 0. So this is a one approach. So what I am selecting the subset size from the given set, which is size is 0. If it is size is 0 means it indicates that there is no element selected from the given set A. So set is no elements means the subset will be 0 only. So subset sum will be 0. This is the one brute force applying because of I don't know which number, either 2 numbers sum will be the 13, maybe 3 numbers from the subset may be 13, or 1 number may be the 13, or 4 numbers including maybe the 13. So that's why what I am saying, I am searching the all possibilities. So this I can say it is a brute force approach. So that's the reason I am selecting from starting from set size 0 to size n, which is the equivalent to the set size. So that's why I am saying first size is 0, next one size 1. So size 1. So size 1 I am selecting. Size 1, what are the elements will come? Tell me. So 5 I am selecting one element. At a time one element, should not select the more than one element, because of size is a 1. So 1 is 5, sum is also 5. So 3 if I select, 3 is a sum, minus 1 equivalent to the minus 1, 7 which is equivalent to the 7. So these are the size 1. Similarly, you select the size 2, set size 2. So I don't have any option. I have to select the randomly from the set. So that's why I am picking in some approach, like initially I am selecting size 0, size 1, size 2, size 3, size 4. Where I am getting, I don't know. Because of now, by seeing this one, you may understand this is a 4 element. By directly you can be calculate, but size is more, so you may not able to solve it. So that's why what I am doing. So I am following some approach, that is a brute force approach. So size 1, size 2, size 2 now I am selecting. So now size 2 you select 5 comma 3. So what is the sum? 8, right? Similarly, you select the 3 comma minus 1. What is the sum? 2, right? Similarly, you select the minus 1 comma 7. What is the size? 6. Next, 7 comma 5. What is the size? What is the value? 12, right? Similarly, 5 comma 3 is already get, right? So etc. you may select, like 3 comma 7 which is equal to 10, and so on you may select, right? So now what is the optimal value? Near to the 13 is a 12 one. So now you can do any 2 elements, you will not get the 13 value. So in that case what you will do? You have to select the value which is near to the 13. So that means that 12 is near to the 13. For example, 12 is not come. So what is the nearest one? 11. If it is not come 11, 10 is the nearest one. Like that you have to select the element. So next, similarly we select the size 3, subset size 3. So what is the subset size 3? You select the 5 comma 3 comma minus 1. So what is the value? 7. So next one, 3 comma minus 1 comma 7. So which is a 9. Next, minus 1 comma 7 comma 5. So what is the value? 11. Next, correct? Is correct? 7, 5, 12, 11, correct. So next one, 7 comma 5 comma 3. What is the value? 15, right? But as per our condition, here it is a 15 is a greater than 13, right? So we will not select the 15 as a solution. So that means that the solution should be equivalent to 13 or less than to the 13, less than or equal to the 13. So 15 is a greater than 13, so we will not select this value. So next one, size 4. Size 4 will select. So that means that 5 comma 3 comma 1 comma 7. What is the total? 8, 7, 7, 14, right? So 5, 3, 8, 8, 7, 7, 14, correct. So that means that 14 also not at all solution. So this is the brute force approach. So as per what we discussed in the previous one, previously this time complexity is reduced to the 2 power n to the 2 power n by 2. So that one we will see how it will be reduced. So now you understand how it is summation is getting, right? Now we will see the what is the time complexity for this brute force approach, so that you will understand the clear. So what is the time complexity? So later on, what is the approach? Meet and middle technique will reduce this one. So that one we will see, so that you will understand very clear. So now I am going to explain what is the time complexity for doing this brute force approach, right? So now what is the next? So what is the set size? 5, 3, minus 1, 7. So what you are doing here? You are selecting the sum element, right? So you are selecting some of the elements from this given array. So how many ways you are selecting 5 here? Either you may not include the 5 or you may include the 5, final set, correct? So here it is, you are not include, here you may include. Similarly, size 3 also you may include, don't include. Similarly here, set 0 you may not include or you may include, right? Here also you may not include, here you may include, here also you may not include, you may include. How many ways you can include the 7 to the solution set? 2 ways. Similarly 1, similarly 2, similarly 5. So how many choices are there to include the 5 in a solution set? 2 ways. 3, 2 ways, right? 1, 2 ways. 7, 2 ways. So now how many total ways are there including a solution set? Each number 2 into 2 into 2 into 2 into 2. Sorry, not these 2, only 4 2s, right? So that means that why it is multiplication? Because of, for example, you select the 5, right? This is a, you select the 5, either you may not include or may include. So why it is into? Because 5 alone may get the solution or may some other number also include, either maybe 3, maybe 1, maybe minus 1 include. So how many ways? That is also 2 ways. So this is the 2 ways, this is the 2 ways. So that means that, for example, you take the 5 is not included, 5 may be included. So after 5 is not getting the solution. So similarly, next element, that is a 3 may not include, 3 may include. If 3 is include, next 1 may be not include, may be include. If 1 is included, then 7 also may not be include, it may be include. So this kind of approach is following. That's why in multiplication is keep. So now 2 into 2 into 2, what is that? 2 power 4. So can I write big O of 2 power n? Yes, I can write. What is n? N equal to 4 here. So what means that in what is the n value? 4 here. So time complexity is big O of 2 power n for brute force approach, right? Next we will see the one more strategy to solve this problem. So what I am doing? So same problem, I am taking same problem, 5, 3, minus 1, comma 7. So initially previous approach, what is the time complexity is taking? 2 power n. So now I am applying the meet in a middle technique to reduce the time complexity from 2 power n to the less. So this is the strategy I am going to apply, right? So now what I will do? So what is our meet in a middle technique? So problem will be divided into 2 independent sub problems equal size and solve the separately and store into the final result. So this is the meet in a middle technique. So now what I am doing? So problem I am taking s equal to 13. So same problem I am taking. So divide this problem into the 2 halves. So that is a 5 comma 3 is a 1, next one minus 1 comma 7. So divide this one. Now you apply the 2 pointer approach here. 2 pointer approach. So that means that you pick the one pointer here, you pick the one point here, this array, then try to get the sum value 13. So what I am doing? Similarly, here also I am applying the same strategy. Like first, I don't include any elements from this set. First, I may include the 5, I may include the 3, I may include the 5 plus 3, 8. Similarly, 0, -1, 7, comma 6. So now I am applying the same approach. So I am taking a pointer this side, which is a, let us say, which is a like this you take as a x, this you take as a y. So these two pointers we are going to take, right? So what is the final solution? My solution should be x plus y sum less than or equal to 13. So this should be my final solution, right? So sum is 13. I have to select the one element from x, one element from y. So it should be less than or equal to 13. So this is my sum. So now what I can write? So select the x value from this left hand side. For example, 0. So what might be the y? Y may be the 0, maybe the -1, maybe 7, maybe 6. First one you select the 0, that is 13. So this is not in a 0 plus 0 less than or equal to 13, but it is not in a optimal solution. So just you take one variable, any variable like int value, so store this is 0. So you come for take the first 13, you get the solution is 0. So next 0, you select the x here, y value increment it. So -1, so -1, so which is less than or equal to 13. So integer value replace with -1. So similarly you select the 0 plus 7, so less than or equal to 13, which is 7. This is 7. You update this value 7 because of 7 is better than 13. Similarly 0 plus 6 less than or equal to 13. So update this value 6 again. So every time you keep on updating. So now next increment the x value, that is this is x. So that means that for each x value you are iterating y, total y here, right? So in that case so this problem somehow it is reduced, but not at 100%, right? So what you are doing, again doing same approach, same strategy, but it is not to the optimal to the solution. So in that case what you will do, 5 you select the x value 5, y value 0 less than or equal to 13. Similarly you found all these things, you will get the 5 plus 7 less than or equal to 13, which is a 12 is less than or equal to 13, right? So this is the optimal solution. You calculate 13 will never come, so you will get a 12 is the optimal solution. So this is the solution. Now question is that what is the time complexity for given problem. So now what you are doing, similar approach, instead of doing all these things, so you are doing somehow reduce the array into the n spaces to the n by 2. So initially you search the each and everything. So what you have done is now doing everything, you half of the space you reduce to the n by 2, something like that, right? So now we will see the what is the time complexity for this one. So what is the time complexity, right? Here it is a 0, right? So now what is the time complexity? Array will be divided this into the 2 power n by 2. This also array will be this array also divided into 2 power n. That means that this entire array is divided into the 2 power n by 2, 2 power n by 2. So what is the total time complexity? 2 power n by 2 into 2 power n by 2. So total time complexity 2 power big of 2 power n. So that means that it is not reducing the time complexity. So can we do something extra to get the reduce the time complexity? You can do. So how we are doing, we will see now. So that so this is also between middle technique, but this approach 2-pointer approach. So 2-pointer approach, you are not getting the you are not optimize the time complexity. So now we will see, so that you will reduce the time complexity. So that I will tell you. Be hold on line. So what you will do, same thing will do. So problem will be divided into the two problems again, but we will apply the not two pointer approach, we will apply the something else, so that you will solve the problem in efficient manner. So what is the way here? You apply the 0, 5, 3, 8. Right, left side same, right side 0, -1, 7, 6. So this is the earlier one. So in a third approach, what you will do, you apply the sorting technique on right side array. So it will be remain same. So what will come? -1, 0, 7, 6. Sorry, this is 6, this is 7. Right. So what is, you can apply any sorting technique. You can apply the binary search technique. Binary sorting technique, so that it will be reduced. So that means that so it will be like 6, this is 6, this is 7, right. So now what you will select, what is our problem? X plus y less than or equal to sum. Now y, what you will do, y, can I write y less than or equal to sum minus x. So this way you can select, right. So that you will get the solution. So that means that you pick the y element such a way that should be sum minus x, right. So that means that x you pick the element in this one, y you select in such a way this satisfies the condition. But instead of searching this one, instead of searching entire array, you apply this strategy. For this one, you apply the binary search. You apply the binary search, so that time complexity will be reduced somehow, right. So what is the solution for this one? Binary search. So binary search will find the log n time. So log n time it will found, that is a log to n power 2 power n by 2. So this one is a time complexity for finding the element. Apply the lowest binary what you can say, lower bound of the binary search, so that you will get the solution. So now what is the total time complexity of using this one? This one anyhow n by 2. The problem is n here, so it will be n by 2. So that will be the left side is n by 2, right side is 2 power n by 2. So the total time complexity by using this approach is a big O of n into 2 power n by 2. So that means that somehow time complexity of 2 power n reduced to the this n into 2 power n. So you may get confused here, so don't get confused. Here it is a, as it was there earlier, it will be remain same, right. So here is what you are doing, here just applying the sorting technique on this divided array by using the binary search lower bound, right. So now instead of directly finding the element, you apply the this formula, y is less than or equal to sum minus x. So that means that, so here there is no shortcut here, we are going one by element only that, but it is killing too much time in a right side array. So that's why we are reducing the time complexity from right side array somehow, that is like what we can say, somehow you are reducing time complexity by applying the sorting technique, so that instead of searching each and every time, so based on this condition, you will find the solution. So that means that y less than or equal to, what is sum is 13 minus, so that means that y value less than or equal to 13. So that means that y value less than or equal to 13 means you will pick the element which is less than 13 here directly. So no need to go for entire sets, right? So now y is less than or equal to 13, simple. So here it is, there is no value which is less than or equal to 13. That means that less than 13 value should be there, pick the right hand side. That means that, simple, I will tell you, just try to follow me. So y less than or equal to 13 equal to x value, so right. So that means that this y value you are going to pick which is less than 13, less than or equal to 13. So that means that here all values are less than 13, so you can pick any value, first point. Second point is 13 is there, but problem is that you pick the highest value, your problem is solved, because of instead of all values following the condition, this one less than or equal to 13, you pick the better one, biggest one in the array, so that it will get the optimistic solution. So which is the bigger one? 7 is a bigger one, that's it, solution, right? Here you select the anyhow, you will iterate this one entirely, but you select the bigger one. So that's the reason you are reducing the time complexity somehow, which is a big O of n into 2 power n by 2. So this is the total time complexity for solving a sum of subset problem. So I hope you understand from how it is meet in a middle technique is reduce the time complexity from 2 power n to the big O of 2 power n. So just I will give the brief entire conclusion of this lecture. So just a second, try to erase, so that you will get a clear understanding. So what is the brute force technique is doing and the meet in a middle technique is doing, so that you will recapitulate at the last moment. See, so what is happening is, first point is there is a set 0, 5, 3, 8 and again -1, 0, 6, 7. So what is the total array which is there in problem set? Problem set is the 5, 3 minus what is the problem set? Problem set is a 5, 3 minus 1 comma 7. So this is the problem set. So what you are doing is, first brute force technique, you are applying the picking the one element from this one, picking the one element from this one, you are searching. So that is a brute force technique. So simple, 5, 3 minus 1, 7. In a brute force technique, you picking with 5, 3, 5, 7, 5, 1, like that, 3, 3, 7, next this one, this one, this one, each and every element you are searching. So that's why big O of 2 power n. Next one, what you are doing, divide into the 2 power n, 2 power n. So that will be the big O of n into 2 power n by 2. So somehow time complexity is reduced from 2 power n to the 2 power big O of n into 2 power n. So thank you for watching. So if you have any doubts, please comment into the comment section. Thanks for watching. Please like my video, share and subscribe to the my channel.